Hello, hi everyone. Welcome back to our channel. Here in this video, we are going to discuss about some core concepts of DevSecOps. What is DevSecOps? The goals of DevSecOps, what exactly it achieves in a business perspective, and some core components in DevSecOps pipeline, and what are the some best practices need to follow while establishing or achieving DevSecOps methodology, and understanding the categories of DevSecOps tools. And in those categories, different tools will come, and we also see key DevSecOps skills and techniques what to follow, and finally we also going to see some DevSecOps challenges as well. And without wasting further time, let's enter into a video. And I will also finally share this particular resource and tell how to know like recent things in. I mean, based upon my experience, I'm going to share some tips at the end of the video. Now, without further ado, let's enter into the video and start this particular video. First of all, what is DevSecOps? DevSecOps is like a culture or methodology like DevOps only that emphasizes a shared responsibility for product security across a development, security, and operations teams. By integrating a continuous and automated security scanning for software and cloud infrastructure into a software development lifecycle, that is SDLC. Especially DevSecOps aims to empower engineers to consistently deliver a secure code. Okay, understand this line, secure code, where the security is security is shifting to the left. That means priority is security, later the task is going on. Now coming to the goals of DevSecOps. The first goal of the DevSecOps was that needs to reduce reduce security and business risk, correct, by continuously detecting software and cloud infrastructure vulnerabilities before they pass into a production. Before they are entering into a production only, in the development team itself, it was identifying. Especially the development team can mitigate that particular business risk of the application security issues that provides a malicious actors with the sensitive information. And the second thing was accelerate a sorry. The second pointer was the DevSecOps goal is to accelerate developer velocity, more innovation, more productivity from the developer. DevSecOps aims to empower engineers to deliver secure code from the starting phase itself, rather than finding the vulnerabilities in the production and training them back to the developers. This accelerates a developer's velocity, where it avoids a time to consuming feedback cycle between development and security team. How the DevOps methodology flows. And the next goal is to achieve compliance requirement faster. Like modern compliance requirements demand the continuous code scanning and vulnerabilities remediation to reduce especially the security risk. By implementing DevSecOps practices, businesses can deliver secure code faster, which is reduces the time to needed to fulfill the compliance requirements, so that they can sell into your market faster. And the next goal was they need to build a culture of shared responsibility for security. Secure software delivery requires a collaboration across the development, security, as well as operations team, as discussed. DevSecOps makes a security testing a core pillar of CI/CD, software development lifecycle, which builds a culture of security across the organization level. And the last goal is to improve the secure software development skills. It was quite interesting. By providing a continuous and immediate feedback on the code security, DevSecOps can help developers to understand the security implementation of their coding decisions. Especially over time, developers can better understand common security issues, and they can definitely resolve them themselves. And these are the some goals of the DevSecOps. Let's go with what are the components in DevSecOps. Especially the pipeline which is showing on the screen, it integrates a automated security testing into each phase or stage of the software development, starting from plan, after that code, after that test phase, after that build, after the test, again release, deploy, and run. Let's go step by step. What exactly in planning phase? There is a dedicated tool called threat modeling, or different service providers are there for planning. Azure also provide Microsoft threat modeler as a planning phase. In planning phase, it requires a designing applications, that what are the requirements is there, and that will securely design based on the principles. What all the things need to be implemented, and duties of the engineer, and ensuring the list privileges, and requiring throughout the authentication and authorization of access request. We are going to the plan in the planning phase. After that, code scanning in the IDE. It is in the development involvement. By scanning code, it's being written in the IDE, developers can catch the vulnerabilities early in the lifecycle development, and then they can resolve the production issues in the early stages itself. And there are a wide variety of service providers in those plugins also available. You can explore that if you want. And pre-commit hooks. What exactly the pre-commit hooks do was it will enable your developers to test their particular code without committing into your production or staging into your existing code base. This particular pre-commit hooks can help for security scanning, like a secret detection, where you don't want to record any hard-coded secrets in your source code management, that is SCM. And the next thing was CI/CD integration. By automatically integrating security scanning as a PR, that is pull request, can be created, developers can ensure the security of every code change they merge into a code base. Look for a solution that provides a extensive remediation guidance for vulnerabilities within a pull request, so the developers can quickly resolve their issues. The next phase was build phase, where the coding languages, especially Java, Gradle, can also be scanned as they are being built, which is why many DevSecOps pipelines are focusing on the build phase. And the next phase was deployment-based scanning, where in this the configure automated application and cloud infrastructure scanning after each deployment to ensure any new vulnerabilities are being passed to production. The final stage of the DevSecOps pipeline verifies the security of the application in the production level. This is the like what are the different components of your DevSecOps pipeline. And coming to the some best practices of DevSecOps, it will integrate your continuous security testing and into your development environment, especially as I said in the IDE phase itself, it will integrate a security and without making a pull request in the by using pre-commit hooks, it can be achieved. That is the one of the best security practice, and integrating in the IDE, that is also one of the best security practice. Focus analysis on the code change, that is the one of the best practice. And security for developers, this also covers the first and second pointers. We need to implement auto remediation, okay, where let's say if you found some vulnerability in the code base, developers often need to conduct some research about that and some perform your root cause analysis, and they need to make sure like it is not going to happen in further upcoming. And the last one was they need to prioritize the vulnerabilities based on the runtime context. That is the one of the best practice, we can say. And there are some pointers regarding understanding the categories of DevSecOps tools. It is quite very much important, as if you are in the DevOps or DevSecOps space. There are different categories like secret detection, SAST, SCA, IAC, and CSPM, DAST, SCM. Okay, there are different set of tools will fall under different categories. First of all, let's deep dive into this particular SAST category. First of all, let's go in and discuss about what are the different categories. There are many different kind of applications of cloud security vulnerabilities of each which requires the different scanning methods to detect any of the vulnerability bugs or any secret detection. Let's explore some different categories. We'll work for each and every vulnerability or misconfiguration or bugs, whatever it may be. And we are also discussing what are the some pros as well as the cons in that particular category. First of all, let's go into SAST. SAST in the sense static application security testing. The main advantage of SAST tool is to it is a great for detecting coding issues like injection attacks and buffer overflow early in the software um, development lifecycle, and it will consider integrating SAST into the integrated development environment IDE or continuous integration CI/CD pipeline system to automatically trigger a analysis for each commit what the developer makes. And the some disadvantages we can say by using this particular SAST was are known highly for false. There are some false positives, and it will detect that also. That need to be manually validated after that. And the second category was secret detection. In secret detection, the main advantage is there is a wide variety of tools like a GitLab, GitGuardian, Trufflehog, where it will detect a secrets in crucial like a components of your DevSecOps toolchain. They particularly scan the source code, and that will detect any hard-coded credentials such as API keys and passwords that could provide a sensitive information like credit card information or some health records, malicious sectors. And this is the some disadvantage we can say, because these tools focuses solely on the secret detection only. To convert the rest of the product security landscape, you need to implement other technologies which can lead to a tool silence. And the next category was software composition analysis. We can say SCA. The main advantage of SCA is it is required to identify some vulnerabilities in open source software components and their dependencies as well. By considering how often open source is used in modern applications, it is very crucial to ensure software supply chain secure with a software composition analysis. There are wide variety of tools, especially like Trevi, Snake, SonarCube, and well, a wide variety of tools. And coming to the disadvantage, many software composition analysis tools rely on the National Vulnerability Database, which documents which vulnerabilities exist within the specific open source components. Many of these vulnerabilities don't contain much remediation guidelines, which can leave the developers unsafe or not how to fix that particular issue. And the next component was SCA, that is, IAC scanning, infrastructure as a tool, as a code scanning. The main advantage for this was without careful inspection, or IAC can be easily contain some vulnerabilities also. And let's say if S3 bucket that exposes a sensitive information, where attackers might look on that and steal that particular data. And considering IAC scanning catches that particular issues in the before the production. And some disadvantage of this was the nature of this particular IAC tools is to surface vulnerabilities in static IAC files only, which will miss the vulnerabilities caused by configuration drift and other issues caused by the infrastructure changes dynamically and made on the CLI changes or any cloud console. For this, a CSPM below is especially needed. That's why the CSPM, Cloud Security Posture Management, came into picture. The main advantage of Cloud Security Posture Management is that will scan your live cloud environment, especially. The name itself suggests the cloud security, not on-premise. any misconfigurations are there and any vulnerabilities. Unlike ISC scanning, it can catch up the issues caused by the configuration drift, and which changes dynamically in the cloud console as well as CLI, wherever it might be. Okay. And the next pointer was dashed, that is dynamic application security testing. In this particular tool, it will analyze the apps from the outside in. Remember this particular point, it is outside in. From outside only, inside it was scanning by simulating the attacks in the application. Like black box testing method interacts the running application without accessing its source code. And there are different kind of tools like Fortify, Sonotype, and many more, which supports the WAPs, ZAP, which supports the dashed category. And the con of this particular dashed category was it will only analyze the live applications. So it cannot be used as a shift security left in the software development lifecycle of surface issues before the production. Why? Because the application need to start and running live, then only this particular dashed performs its tasks. And coming to the another category, it is source code management, misconfiguration, SEM we can say. The main advantage of this was without security control in place, source code management can be misconfigured to expose cause sensitive information to the public environment, and that will implement a code repository configuration consoles to ensure your code isn't accessible to the some malicious actors. This is the main advantage, and the main disadvantage of this particular source code management is SEM security tools mainly point solutions. So you'll need to separate a security tools to cover the other categories, especially to sense the tool any misconfigurations or whatever it might be. And those are the like some what we can say categories of your DevSecOps. And coming to the key DevSecOps skills and techniques we can say, make sure as if developer or if you are working with a developer or different teams, you need to make sure you need to familiar with the development environment and IDEs and how the code is flowing, what exactly it was. Don't consider the in-depth logic, but understand what exactly the code is doing. Okay, based on that you will your productivity high. And every tech stack has a unique risks and security challenges. DevSecOps ensures it will be needed to map the system with they want to secure, whatever they want to secure, and research the best security controls on their particular stack, what they are using. And you need to implement those security controls in their ways that won't obstruct the developers' development or any innovation. You need to monitor for issues and need to generate reports, and you are able to demonstrate the complaints and the process, what exactly it is happening. That is the main techniques or key concepts you need to be familiarized as a DevSecOps engineer. And communication and teamwork, definitely communication is very much required. As a DevSecOps engineer, we should need to be integrated or need to collaboratively work with the different teams to seamlessly flow the things as it is. And however, the security process can make a significant impact on the developers' workflows, which that is why especially the DevSecOps engineers should work closely with the developers to build out of the practices of their work. And additionally, DevSecOps should align with large security objectives like aligning compliance with the specific standards and some international standards, which requires the teaming up with the information security teams to ensure production security goals and align it into them properly. And risk assessment and threat modeling techniques, this will cover in some key DevSecOps skills and techniques, where as a DevSecOps engineer you need to analyze the risk and you know to maintain a certain security throughout that particular flow pipeline. And there are some challenges as well being a DevSecOps. These are some challenges. The first one was false positive. Especially DevSecOps requires a trust in the results of security scanning, which that is why the false positives are perhaps the fastest way to erode developers' faith in the results. Spending time to research problems that doesn't end up the posing real risks, wasting developers' time, and creates a new associated with the security best practices. And the second challenge I can say it is there is a long backlogs of unprioritized security findings. We need to work on that. And context switching, it is also one of the major what we can say challenge as a DevSecOps engineer. Let's say most security process and technologies requires developers to leave their environments like their IDE or the SCM, source code management, to find some research and resolve the vulnerabilities. This takes them out of their workflow, and they would rather be working on the next future. And by having this particular DevSecOps, they need to ideally sit in their development environment or Git, whatever it may be, and they are not going to work on the upcoming future or some new innovation. That is one disadvantage we can say. And developer busy in, yes, as discussed earlier, DevSecOps requires here a developer buy-in. We need to get the time out of developer, where it will as a DevSecOps, it will shapes the culture as a shared responsibility to deliver and maintain a secure applications. And pulling out the product like a security burden on the security team. It's scalable, okay? And there are too many vulnerabilities, and developers are better passionate to make the necessary fixes. And these are all the challenges we discussed above, and some security techniques as well. And these are some overview about the DevSecOps as a pipeline, as a categories, and some goals. And one more thing, if you wanted to know more, learn more about this, any of the technologies, kindly prefer the blogs rather than kind of videos. Why? Because if you refer your blogs, there might be some technical experts from the organization. They have written these kind of blogs, and that might be helpful for you. And that will get you some basic fundamental strong understanding. And also refer to your friends or colleagues who are interested in this particular domain. Thank you.